long enough to do whatever they're going to do to my phone. So that's a plus. And they were one of the first to see the RVF format. So let's see if my quantum encryption keeps. Anyway, good to see everyone. And we don't have Rob today, but I think he had to take off. But Jed, you were saying.
So what I do now, I'm getting to the point where I'm becoming model and coding agent agnostic. And one major problem is sharing knowledge or learned attributes. Now we have many different layers and solutions that are memory focused, but the problem I have with those solutions is they are centralized and it becomes a bottleneck when you have up to a dozen agents trying to learn something or recall something from that memory system. So what I've done instead is to capture the discussions as a transcript across all agents and then set up a different search platform so it scales horizontally to allow them to search each other's transcript in order to learn solutions to previously uh, solved problems. And at
Okay,
least for
okay.
now, it's allowed me to scale to multiple concurrent servers, each hosting multiple agents, communicating amongst each other in in an indirect way, sort of the same way plants communicate with pheromones, to ensure that learnings from solutions to problems persist across the entire collection of agents. I hesitate to use swarm because it implies unity among them, and this is very intentionally ununified.
So how's
More
that?
like a mycelial network.
Yeah.
That's a good way. Yeah,
And,
mycelial network. That's a good way to describe it.
and how does
It is more
that
like
differ
every,
from like the sort of, graph GNN sort of vector approach that I take, where I'm saving trajectories and optimizing that structure?
that is centralized. So
No,
my
it's
understanding,
completely decentralized.
but
I
how do you
decentralize.
maintain state if
I
is each agent then supporting their own version of that graph,
Yeah, that's exactly what's
or is
happening,
it a
and
central graph?
it's a decentralized graph. So it depends. So it depends on what it needs to sort of understand. But I separate the process of learning the state, like all the information that goes in the requests and the code and the errors, and then I use reinforcement. But the important part is after the reinforcement part's done, I've learned everything I need to do. It creates a kind of internal knowledge or skill. That skill is transferable using a transfer learning. So I'm not transferring like the steps to get to the ability to learn to understand. I'm transferring the trajectories that allow it to then use those skills later that traverse both the vector space and the graph itself. And then I apply that with a GNN. The GNN
So
allows it
how
to sort
does the
of have the
eventual
attention.
consistency occur? How do
Well, depend.
disparate,
It
decentralized nodes synchronize that knowledge?
Well, it depends. I've got a few different approaches, but generally I use, well, for networking, I use, Quick, which uses eventual consistency on a networking layer for the handshake. Then on the sort of the consensus basis, if I have a lot of resources available to me, like a normal sort of VM, I use Raft. If I don't have a lot of resources available to me, then I just export the deltas. The deltas allow me to basically send just the key bits of mathematics that are required that allow it to traverse that information quickly without having to send anything more than the most minimal viable component, which in this case is the delta, or that what's
So
like what
how do
looks
you
like.
avoid factorial scaling? So if you have four agents with with four independent vectors that are all learning from themselves, you have agent A
Are you
teaching to
talking about drift?
BCD. No, 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 not drift. How do you, when you're maintaining that synchronization, I have in a pool of four agents,
Mhm.
I have agent A with its learnings. Uh, the learnings will transition to B, C, and D. So that's one set, three. I have B pushing its learnings to A, C, and D. I have C pushing its learnings to A, B, and D, and then D pushing its learnings to A, B, C. So those are, what is that, 12 connections between in a pool of four agents. So that means a pool of five agents would be even more. How do you prevent that scaling?
I'm not sure if I quite understand your question, but in the what I can show you is
Okay,
it's
it's decentralized,
what I can show you
and
guys
you
is how I'm doing it on my Nano, or sorry, my Zero. So back to my zero for a moment. I can connect multiple of these together in a swarm, right? So in this case, multiple little devices that are essentially embedding root vector on this. It's basically Raspberry Pi Zero. And so I get 512 RAM, and this got a 16 gig SD card in it. So limited resources. It's got four core processor. Now, what I want to do, similar to what Jed has mentioned, hopefully I'm sharing the right screen here, is I want to share the resources, across them. So this is the dashboard for just a single device that I've connected to. Now, in this device, there's a variety of different components that I can connect to and run locally or within the browser itself. So I pair it, and then once I have that, I've also got a swarm capability. So the swarm again allows it to understand itself and some of the other available resources. Now, I don't have any other resources currently connected to this particular one because I just ran a quick on this environment. But hypothetically, let's say that let's say that I connected two of these or more. This system then it has the ability to communicate with which each with all the other available nodes in that swarm. So in this case, the most basic here is I've got a synchronization element here. So the synchronization element again provides this, a delta pull or push, right? I'm pushing, pull or pulling depending on what's needed. Now, I'm using it in a sparse sort of setup, so it's not constantly doing it, right? It's monitoring. I don't know. It's hard to describe it, but it's monitoring the integrity of the overall system and then saying, based on certain characteristics of that system, is it outside of the bounds of the acceptable operations? Has something changed? Does something need to be pushed or pulled? At which point the system sort of wakes up, or at least that particular agent or process wakes up and then sends in that or pulls that information. So in the most basic sense, these what is it, four components provide the ability for me to sort of understand who or what is available to it and then sync. So in this case, you can see here in this particular curl, it's pulling changes since a certain sort of epoch was run. So think of a GNN and learning compilation. So it doesn't have to learn all the time. It only needs to share bits and pieces that it needs to share. Now, in this case, you can see here that it's essentially returning the vector. So I'm sending purely just math, light, and the math is just the specific thing that changed in the vector store itself. So I'm not communicating it in the way that you would communicate like an LLM. I just changed 50 files, and here's an MD describing all 50 files that changed. I'm just updating the particulars in the shared vector store that the system can then understand in correlation to everything else that's happening. Now, I know it's kind of a weird concept. I'm communicating in math, right?
So
And
you
that
have
math,
this state. Is this state
yeah.
duplicated across every agent, or is there some centralized aggregator of state that all the agents consume from?
There's a centralized. It's not. Centralized is the wrong term. It's not nothing central. Well, I guess if I'm running one of these boxes, then it's centralized. But once I've got multiple, chips or appliances or these sensor bots, I can then sort of aggregate those in a decentralized fashion. The most obvious sort of use case for that would be like I don't know, decentralized witness, where I can have multiple untrusted devices all collaborating and learning, and one might get exploited because it has physical access. Someone takes out the SD card, pops in one that is now exploited, but it doesn't take down the whole entire system. It assumes everything has zero trust. So I'm in a position where when I don't trust anything, then I can sort of understand the nuance. So I guess it's hard. Again, I don't have the easiest way to explain it, but long story short, I expose all the components in a variety of different API calls. Now, everyone loves MCPs, and I love to pick on MCPs, but I'm essentially creating an MCP device, right? So here are all the different endpoints relating to like loading kernels or RVFs. These aren't all the capabilities. These are just the most important capabilities for sort of interacting with my system. For beyond this, use the API itself, which would have quite a bit more. So you see here like upgrade endpoints. This is the hardware that's running. And then these are the GPIO is an interesting part of this device. Back to this device for a moment. if you look, I don't know if you see my screen or my face here, but it's got a 40 pin sort of GPIO. So what this does allows me to connect sensors, right? And the sensors could be like environmental sensors, HVAC, heart monitor, whatever I can plug into this, and then the system is able to read the data from that directly, and that can be in the form of wave, which would be like a hertz or a gigahertz kind of signal, but it can also be sort of a kind of pattern-based signal, and that signal might be like your information coming from, well, the opposite of a brain scan. Maybe it might be like the information coming from, I don't know, heartbeat, possibly, like a human
So
heartbeat.
in a collection of, let's say, four Raspberry Pis, how do they synchronize their state, or is their state even synchronized? Do they all connect to each other,
They're
or is it
synchro.
more
I'm
like
just,
they
I
connect?
just showed you. It's the sync API point
Right,
that
but
synchronizes the state
who?
in a vector
But
form. It's all stored in a vector. I'm not sure how else to describe it. It's not text, if that's what you're asking.
it's not about the text part. So in my case, for just to simplify things a bit, state is a learning or a representation of a learning. Could be vector, could be text, could be image, or just straight binary. What I'm trying to understand is node A in an ABCD network learns something. How do BCD get it, or get that learning, or even need that learning, or know that they need that learning? Does that mean it's synchronized from A and then the vectors are adjusted? What about if B, C, D are individually learning separate things? Do they then synchronize back to A? Because that then implies every node would need to connect to every other node, and that becomes, well, that increases the communication overhead the more nodes you add to the network.
That might be a question for ChatGPT. I'm not
I've
really
asked
sure
it,
how to
and
answer.
the way I
Yeah,
solved it is
so
basically everything is
let's
independent of everything else, and they commit to a shared repository or pool where, while they have access to all the data, they are not explicitly querying all the data. They're querying what is adjacent to their knowledge. So the
gotcha.
best way to describe it, I have a sandbox. There are four sandcastles being built, but the knowledge of the other three sandcastles is not fully available to the agent
Mhm.
until they dig a moat to the corresponding castle.
So what question am I asking here? How are we handling decentralized state across multiple?
What
And
I'm
I'm
trying
doing
to
this in a variety of
understand,
different ways. Multiple like agents. It's not really an agent structure.
what I'm
Multiple instances of vector. I don't know, something like
So
that.
what I'm
That's
trying to understand is how multiple invocations on root vector, each presumably attached to individual agents, are able to coordinate, learn, or um, merge, or I guess coordinate or learn from each other. Because I know it's a stated feature, I haven't been able to use it. And this is after having Claude Code and Codex going through the code base to try and identify it.
All right. Well, let's get to the bottom of it and see what we can find out. Maybe I'm not articulating myself. We'll come back to that in a minute. So one of the things I want to show you guys today, last week I was at a hackathon, and I've been playing with the RBF format. Hopefully, I'm
We're
sharing two
seeing two
screens.
screens, Rue.
Yeah, can you see both screens? Is
They're
it too
pixelated
small,
for me.
or does this work for you guys?
Too small.
It's very
Too
pixelated.
small? Oh, it is? Okay, let me I'll come back to Jed's question in a bit. All right. In the meantime, so the RBF format is pretty cool. So what you're looking at right here, you see I'm running everything in a self-contained RBF package, including the Linux runtime, Vite style Vite.js dashboard with Three.js running, and a self-contained vector store to basically find various forms of communication in the sort of, or not communication, planets in the solar system and galaxies and whatnot. This is basically just Three.js visualization of the system. Now, what's cool about this, again, it's self-contained. So, much like what I was showing you here on the appliance, this could run directly on, a chip or an appliance, or completely independently of a cloud-based environment. No cloud required. In this case, I embedded a small language model as well. So what that does is, first of all, is allows me to do things like a blind test. So when I'm going and trying to find planets, these systems, as you guys are aware, can create very convincing fraud, right? It's or very convincing simulations of things that look true but aren't actually, right? So in this case, what I did is I started with a blind test. Once I built the system, I then said, can I find the same things that have already been found without revealing the things that I'm looking for, right? So one of the problems you have with a language model is there's a tendency for the language model to tell you the answer because it's been trained on the data that contains the answer. Now, in this particular scenario, I'm not using a language model. I'm using purely mathematical sort of structures that underpin it. So I'm looking at a kind of vector, in this case, a quantum style vector space to see if I can find the same planets without telling it where those planets exist. It turns out I was able to do that quite quickly. So I was in the 10 planets that were found recently. I was able to find those planets using a blind test with 100%. Well, according to this, 94%, but it's 10 out of 10, so that's 100% to me. So now that I have that, I'm like, okay, can I prove it? One again, second problem of language models is this idea of the witness, right? And each of the steps involved in actually finding a particular element, or in this case, a particular planet, and defining how in which that was found. So within the pipeline of steps I need to do to find these things, I need to validate and hash or cryptographically verify each of the things I needed to do to find and discover the thing. So think of like a proof, it's basically proof of work. It's a proof of work that sort of proves that each step that has happened and in how it happened. Now, more importantly, it uses a seed because it's deterministic. That means when if I give you this RVF, which by the way you can go and run yourself, it's in the examples folder. Where the heck did I put that? Let me just make sure I remember where I put that. It's in examples RVF, causal atlas dashboard. So if you go into the RVF folder for a moment, you can run this yourself. And then you'll see there's an examples, and then you'll see causal, causal atlas. So this is the appliance. So you can run it again, self-contained. You can make it as an R in a RVF format. Where did I put those? Where where is the RVF? Anyway, long story short, it's a self-contained file that includes all the sort of learnings, all the process. It includes the Linux kernel. In this case, I can then go and understand each part. So if I want to look at how it found a stellar parameter, and when I see the first step, RVF store opened, Genesis anchor created. Step two, it did ingested the sort of various information for a particular candidate. It did some more studying of the periodic signals, which is basically, I think, the movement of the planet as it goes behind a star and creates a slight variance in the amount of light coming off the star, I think is what it's doing. So then so I'm able to do that, and this is all happening in seconds by like microseconds. So each of this is being cryptographically verified, so I can basically validate exactly what happens. I can see each step down here as well. Okay, so now I've got the system capable of telling me exactly what's happening inside of this really complex neural network, sort of vector-based system. What can I do with it? Well, let's try to find some stars. So in the world, let's try to find some planets. So in this case, then it's taking publicly available data and trying to determine what the most likely planets are in terms of both their chemistry and just viability. So you can see here that I'm looking at it and then validating the information, which is kind of cool. And there's some other detection criteria. Again, some of this is beyond my ability to explain, but essentially it's finding planets. Once you found the planets, I'm like, okay, can I find life on these planets? And I'm not necessarily looking for life that is human life. I'm not looking for what the Star Trek guys M-class planets. I'm looking for just planets that might exhibit potential life based on biosignatures, which is what I'm doing here. So in this case, and it found a bunch of different planets, some of which are likely not supporting life. This one here doesn't support life. This one doesn't support life. But in this case, I found one that has a 22% chance of sort of biogenic life. Now, when I say 22%, 22% out of in this particular data set, I looked at 5 million potential planets. And so 22% likelihood out of a galaxy or universe of planets is actually really, really high. Like I don't know if you could probably get much higher than that without actually going and visiting the damn planet. But what this is looking at is sort of saying, what the molecular signals, it might be a little small, and I apologize. I probably need to up the font size a little bit here. But this is looking at basically found CH4 in 95%. It found some other sort of habitability requirements, and then it's looking at whether that it's confirmation that someone other than me actually found this planet as well. And right here, it was found in 2023 by these folks, which I'm not going to try to pronounce. And it's telling me the various settings, so that's kind of cool. And this is all happening quite quickly. Now, once I've got that, I'm like, okay, how can I take this even further? Well, the next step is basically, well, actually, I didn't run the discovery pipeline. Let's run that for a moment. So this is the discovery pipeline running Rust in the RBF format. You can see how fast it is. And then, oh, found something here. So I'm visualizing the orbit of the planet and letting like it's telling you the radius. I can switch and you can see different planets have different sort of speeds. So you can see that this one's moving quite a bit faster. I'm just messing around with a self-contained file that includes its own AI, its own reasoning, its own understanding, its own vectors, its own all in that one file. And this is all running, in I think the entire thing is like 3 MB or something. Um, so lastly, there was some research that came out recently, I think in the last month, that said that they've discovered some Dyson spheres. And I'm like, okay, let's take a look at Dyson spheres. So for those who don't know what Dyson spheres are, let's run the search pipeline. I can blind test it. So first of all, I needed to do another blind test. So the blind test is like, can I discover the same things that those guys at I think it was SETI found around these potential candidates for Dyson spheres that exist? Now, for those who don't know what Dyson sphere is, a Dyson sphere is this concept that essentially will wrap an entire star with this geometric structure that basically takes all the energy of the star and repurposes it. So what we're looking for in a Dyson sphere is basically places in various galaxies that have a kind of void, right? So you're looking at this void where you might have a kind of anomalous structure that says, well, there should be a star here based on gravitation and other sort of characteristics, but there isn't one, right? So in this case, I'm looking for the absence of the thing in which I'm looking for, which is perfectly suited for my min cut diagram. All right, so I was able to again do a blind taste test. This isn't food, but blind test, and I found Pepsi. And then what we have is I was able to find again the same results, 7 of 7 results. And then I'm like, okay, let's go find some more stuff. So in this case, what we're going to run, we're going to see what we can find that hasn't been discovered. And here we go. We're looking at again. We run here, and you guys can try this if you want to fool around with it. Ask Claude. Go to my Rue
Uh,
vector and
Roof,
run it. Yeah.
roof. One thing. So this is great, and I've been working on something which is tracking near Earth objects and interstellar objects in terms of artificial behavior and orbital mechanics. And I tried to model and build that in Python. I linked that to you in the chat. So if you maybe want to look a little bit, let's say, closer to our home, I've
I
noticed,
can't I
yeah.
can't really talk about that. One of my clients one of my projects is a suborbital management system for management of near Earth objects, mostly space junk and satellites. So I kind of have to steer clear of that discussion at the moment, but
it-
it's the same tech.
So maybe,
I applied what I'm doing for finding and controlling sort of suborbital or orbital satellites. And rather than showing you guys what I was doing in that space, I applied it more broadly. But it's the same tech.
yeah.
But
So
I can't really get into that right now. I've got
you don't
NDAs.
have to. I just want to pitch some inspiration. So bottom line, I've been noticing some, let's say, anomalous behavior in near Earth objects, which seem to be different than orbital normal mechanics imply. And I was trying to sieve through them and find out if they have certain patterns of behavior in terms of recurring presence in Earth, while trying to disprove the Fermi paradox. So if you have a look into that repo, maybe it's something that might help you achieve whatever you're doing without going into detail what you're
Yeah,
doing.
yeah,
Yeah,
for sure.
yeah,
You,
would
you
be
have me
great.
until Python. Make it Rust, and I'm your guy. But it definitely sounds interesting.
I don't have the
Um,
time and the token. That's the thing.
so the last part that I want to show you guys is the self-learning solver, and this is my most recent addition to my system. Now, the self-learning solver essentially creates a kind of, I don't want to call it AGI because that opens up a can of worms to what the hell's AGI. But essentially, it's a system that allows it to question its own structure, basically creating its own puzzles. So when you look at the configuration of the training, it's self-reinforcement learning in the most basic sense, but it's a self-reinforcement learning that allows the system to question and then form its own sort of causal loops of puzzles that it needs to answer. So when you look at sort of, again, I need to zoom in a little bit. You guys can run this if you want. But you look at the puzzles, I can define how many puzzles it's going to do, how it auto trains each round. Now, I use this kind of auto training, auto kind of puzzle solving system for just about any problem I'm looking to solve, like DNA or whatever it happens to be. And you can sort of play with the settings. I can choose balanced or various other components. And this is looking for sort of mechanisms to discover the undiscovered by telling back to the blind test. How do I find things that I want to discover without telling it the answer to what it needs to discover? Right? And this in particular is how I'm handling that. It's creating that loop, that really quick loop of the ability for it to learn very quickly through sublinear processes. So what that means, and I'm going to try to explain it because I'm on the verge of what even makes sense to me, but basically it's learning in very, very tightly constrained time-based loops. So again, microseconds and below. And then as it goes through that, it's creating multiple sort of parallel tracks that it can then test each of those potential or hypothesis of what those tracks may look like, different planets, different, elements, different things that it needs to understand. And it does that in a kind of parallel or SIMD, I think is the actual tech, so all at once across multiple channels, and then they converge. At some point, there's similarities between all these different parallel tracks, and the system's tracking that kind of convergence of where and how those things are kind of blending together. At which point it says, okay, out of a million or a billion different possibilities, these ones are clustering together in this kind of vector space, which you're kind of looking at here. And we see some of the data in the background, which is kind of a cool visualization of it here. The data and this is sort of doing the pattern recognition. So obviously the red bits here are the parts that are less interesting. The green bits are the parts that where they sort of cluster together. I know it's kind of weird to see here, but I kind of like the visuals. So if you're looking to apply this to other things like business or stock trading, you can literally take this entire thing that I built, point it at my neuro trading system, and say, go find me the best, stocks. But it's not finding those stocks based on the obvious patterns. It's finding it on the inverse patterns of what it thinks it needs to find, setting puzzles, and then saying, how can I solve this problem without asking for help? Again, kind of nuts. Um, Here's my memory system. So I've got this entire thing is in about 9 MB of sort of total storage. This is how much I'm using. Here's my bounds for this will be min-cut. This defines the boundaries of the system. Now I can download this entire thing as an exe executable. So if I want to run this and give this to someone else, I can just download the .exe and or I want to run it on my Mac, DMG or Linux, the tarball. The entire thing is completely self-contained, which is again the part that's most amazing to me. I don't need an operating system, literally running this whole thing on a single device, right? So when I jump back and show you the cognitive system, I'm doing the same thing here. Now, the difference is when you go into, let's say, it mounts it as both a storage system and as a network on your device. So the network would be this 169. My kids said I should have done 167, but I did 169, whatever. I thought the 69 kind of fit into each other, kind of like whatever. But anyway, so you get this launch. So on a Mac, you'd see this when you plug in the device, and if you drag this in here, it's going to do a quick lookup. It was so fast you probably couldn't see it, but it's checking the configuration. Then it takes you back. Now, if you go to the index page, you're going to see just the API. You can test the API at any point. This is the response, and it's super fast because there's no network. I'm literally connecting to the box, so I'm limited. The only speed is the speed of the time it takes me to traverse the USB cable, and to speed it up, I just used a shorter USB cable, which is the most amazing part. So the difference, I'm able to see the difference in speed between a long ass USB cable, this one being fairly long, and this one. So that's actually a measurement of I guess the speed of electricity. Maybe it's not light, but anyway, so the length of the cord actually shaved micro milliseconds off, but I could measure that, which was kind of cool. But when you go in here, you can see like identity, and I can test it.
Depends on the
You
USB
got
protocol you're using, USB 2 or USB-C. Vastly
I'm
different
using
bandwidth.
I'm using USB 3, I
That's
think is what
just
I'm
for
using.
speed. The other thing to consider is how many retries are there over the longer cable, because the expectation is there's some signal degradation until the handshake is reestablished.
I'm not using Handshake. Remember, I'm using Quick. So
Right, but you're
I'm
using
using
the USB protocol, right?
no, I'm using and I'm using the MDNS protocol. So that's a
Okay.
network I'm not
How is
using
it
the USB
converted to the
protocol.
USB driver? Because you're
Well,
not
that I
running
did that
TCP/IP
I'm
over
using a mount.
USB, right?
Yeah, so I'm only using the USB mount for sort of the initial configuration. As soon as this is configured, I'm actually bypassing USB altogether and using in this case, I'm using a Wi-Fi connection, which was faster than the USB connection in this scenario because it's so close, I guess. I don't know.
But you're
So
still
that
running through
that
the controller, right? Because the signal's still passing over the wire through the port, through the USB controller,
no,
over to the CPU.
no, it isn't. It's in this case, it's using the Y, it's using my network adapter. In this case, I can hypothetically, I guess, use the USB controller for that. In this example I'm showing you right at the moment, I bypass the USB and I'm using Wi-Fi. Now I can mix and match, but regardless, it's freaking fast is the idea. And you can see it when I go here and do like a vector lookup, right? The response is almost instantaneous. Right. So it's and these are all the different API sensors. So for in this particular group you're looking at here, these are all my sensors that I might add for again connecting other things to it. And again, to Jed's point, the limit to speed is going to be the mechanism in which I'm connected to the device. So ultimately, I'm connecting a wire to these pins, and I can only move beyond. I can't move faster than the speed of the wire or the USB 3 or Wi-Fi or whatever I'm using. But regardless, it's way faster than any cloud by many orders of magnitude. So in this case here, you can look at my sensor drift history. So the drift history in this particular scenario would be looking at whether the sensor fits within the sort of a learned pattern of the sensor in which I'm looking at. So that could be, let's say, a heartbeat. And let's say this is in a hospital. Now, remember, this doesn't require any external network, no clouds. It all runs completely on this device. So that means it can learn in proximity to the patient in which it's connected to. So worst case scenario, let's say the hospital loses its interconnection, the power goes off. This thing's running on a thermal optimized processor that I devised. So it can run on, again, a AA battery or less. Now, if we want to see how that works, which is pretty interesting, here's all the mechanisms I have for overclocking the system. So I can adjust the frequency of the actual ARM chip based on whether it's doing something or isn't doing something, whether it needs more capacity or doesn't need capacity. And I can overclock this entire chip on this little thing, all 4 cores, up to 30% before it degrades to a point where it's unusable. But for certain things, like when I want to rebuild an index for, let's say, a GNN, I can overclock it just long enough to get that job done. So what takes potentially 1 millisecond at 1,000 megahertz can now happen at 1.3 thousand megahertz, and that shaves 30% potentially off the time it takes you to do that thing. So I'm going from 1 millisecond to microseconds just for that
Aren't you still
particular thing.
bound? A millisecond to microsecond is order of 1,000,
1,000.
right? So
It's 1,000.
how does a
Yeah. So
30% increase in something
I'm
produce 1,000% effect in something else?
well, I'm already on the verge of a microsecond and millisecond. So it's enough to shave that sort of, I'm like 0.001 milliseconds or whatever. So the 30% was enough to drop it under that threshold, which is the important part.
So it's
But it
literally,
is it's a 30%, so 30% only is going to take you to so far. It's not like
So-
30x or anything.
so you're literally doing task-based clocking of your hardware.
Exactly what I'm doing.
0.001 millisecond is 1 microsecond already.
You can play with it. Anyway, so yeah, so what you're seeing here, in essence, is the kind of underlying pattern that exists within what I was showing you here. The only difference is this is the final app, right? This is the final result. But you can see how it's nice and quick. I'm using in this case 3JS for my processor on my laptop in the GPU, offloading that. But the actual intelligence of the entire thing that you see here is all power based on the device that I'm showing you here, or in this, or where, so I can run any of these on this. So in this case, if I want to take it further, let's say I want to download some of my other RVF related components. I've got the ability to, let's go here, RVF, import and export. So I can then import my various, I'm not going to do it because I don't have it handy, but all I need to do is import my data.rvf that I stored, and then I can bring it onto the device. Again, it's a limited size in terms of the device. So you're going to watch out for RAM, and you're going to watch out for the amount of storage. I've got 16 gigs in here, which is pretty good for most of the things I'm doing. But if you want to export it, then you've got the ability to go here and you can export the RVF as well. So it'll build it, and I get different formats here that I can choose from. So I've got, here's my security components. So everyone's like, okay, you built this crazy thing. Like, what are you going to do with it? So I know my most obvious example was the crazy example here of the universe itself, but it actually was useful because it represented a whole variety of things that most deep analytics is going to want to do anyway. It's representing the data in a higher dimensional structure in terms of the vector environment. It's representing it in a kind of causal relationship. Is it learning? Is it adapting? Is it getting better? It's defining drift. Like, is it going outside of the bounds of an acceptable structure? Can it understand what that structure is? All of this stuff here is happening within this system. So taking this and applying it to some other, like a legal platform, or what Rob mentioned in terms of like group of satellites is at this point fairly trivial. It's the same basic structure and information, just with different purpose. So that's what I'm really trying to show here. Let me pause for a moment. I think you asked the question in regards to how I was learning. Let's see if I can find. Did I get an answer to that? Let's take a look here.
I think Stuart had a question.
Sure.
Hey, obviously this stuff is really cool. If we were to take it from outer space and bring it into a business context, I'm having a little bit of a hard time wrapping my brain around how it applies, what it looks like. And have you done this in any of your business clients that you could at least describe what it looks like when you apply it to a concept that's more approachable for many of us who are kind of in that world?
Yeah, the most obvious would be the work I'm doing in the medical space. So
Okay.
the ability to sort of understand sort of the interconnected relationship of diagnostics within a hospital setting, is one of the projects I'm working on, mapping all the sort of information in terms of all the interactions, for example, between the current state of the patient's vital signs, medical history, pharmaceutical sort of interactions, and then providing the mechanism to traverse all that and say, based on all these things, here's what the likely X is, right? So, and I can do that really quickly. So that's like diagnostics, right? Just on a person. Another
And do you
project.
then, all right, but you do that with an RVF? Do you teach the RVF about the domain? Do you store the AI and the data? And I guess I'm trying to understand how much is stored in the RVF and how much is the RVF acting on a data set?
It is the data set. It's all in the same file. There is no external. I bring it all into the one data set. There's no external. There's not like I'm going and calling an API somewhere else. I'm importing all of it into a single file. It all self-contained in one place. That said, I only invented this 2 weeks ago, guys. Like, I don't know. The world doesn't move as fast as I do. So most of the things that I'm doing in terms of the larger projects that I'm involved with are more traditional root, if that's even a thing, more traditional root vector, where I'm basically taking a lot of the things I'm showing you right now and I'm connecting to an API or a data lake or some repository of documents and whatnot, and then doing this kind of causal sort of analysis of it. I just took it a step further and said, okay, rather than having a whole bunch of separate systems in all these different places and all these different clouds and APIs, can I put that all in one package? But that's only 2 weeks old. So,
Understood. And then what's the limit of how much you can compress a universe into this kind of black hole sphere of an RVF that is omniscient? How much can you get in there? I mean, if you're talking a whole hospital system.
A lot, 96% compression. So I use the same sort of compression algorithm I use for like compressing an LLM, quantitizing, I guess would be the right term. And generally speaking, that in more traditional terms is 8 or 4 bit integers. I've settled on a 7-bit integer, which people tell me is odd, but it works really well because it's 1 in 7 is a prime number. It's naturally gives me sort of the benefits of being an odd number and a prime number. So I like it for my quantization, but that gives me, depending on the type of data and the level of which I need to quantize it, remember stripping out all the stuff I don't need and only focusing on the things I do, that generally gives me somewhere between 80 to a 90% reduction in the overall size of the data. Going beyond that, as the thing operates, and keep in mind, I'm doing millions and millions of little tiny calculations, which if stored in just plain text would be gigabytes very quickly. So I'm only storing the important deltas. The deltas are tiny, and those are hashed using cryptography. So super small little deltas that are represented in a vector space that I then can traverse and ask, what does it all mean, and how does it work? And that allows me to run it in on a tiny little chip kind of thing.
All right, thank you. I mean, it's amazing. We're just trying to figure out how to get our head around it and how to apply
I can't even get my head around it. I don't know. I like this, to be honest, this is beyond my comprehension for most things. But it seems to work. So I don't know. All right.
So can you guide a little bit the commands to effectively create the RVF? So how do you do it?
Ask Claude. Just ask Claude. Yeah. You could add, no one's going to type in a bunch of commands. Like if you are, you've got more time on your hands than I do. Ask Claude. Yeah. I built it into my AgentDB. I published that this weekend, and my Cloudflow will have it here shortly. So the entire Cloudflow system was moving from SQLite to my RVF format. But basically, the most important part of it is it uses a copy on write structure. The copy on write structure means if you're familiar with sort of virtualization, if you look at like the WSL in Windows, which is the Windows subsystem, you have to partition that space, and then the maximum it can grow is within that structure of the partition. A copy on write structure allows it to sort of sequentially grow, kind of like a zip file, right? The zip file gets bigger the more stuff you put in it, but unlike a zip file, I've included a runtime kernel and all the other root vector stuff in as different parts or layers within that binary structure. So think of each layer doing different parts of the requirements of that file. One might be, again, the Linux kernel, the other might be the GNN, the other might be a self-learning loop. Those are all different layers within the file. Some things need to expand. So there might be a POSIX style storage area, like what I was showing you earlier in terms of the USB drive, that might need to expand and have more space. That can grow, but it can also optimize itself. So because it's self-optimizing, I can then strip out any extraneous information to keep it tightly bounded. Now, again, I don't. You got to ask Claude if you want something a little more simple in terms of explanation. But the moral of the story is it's portable and it's deterministic. That means you're going to get the exact same result if you run my RVF in some other environment, in some other chipset. It's going to give you the same exact results, right? Where an LLM, even if you set the probabilism to 0, the temperature, the top K, the top P, you're always getting a bit of drift because it's always trying to give you a bit of a probabilistic answer. So it's really difficult to get the exact same result every time. And you'll notice that with the additional adjectives thrown in here or there, the and a, and that, and the other thing. And it's even worse when you start using mathematics. There's no room for drift in mathematics, right? It's inherently deterministic. So as soon as you start trying to say, well, tell me the drug interaction or the folding patterns of a protein, language models just don't cut it. You can't you create a probabilistic description of the protein patterns of a drug interaction. It just doesn't work. This solves that problem. It's explicit, it's indeterministic. So legal, if you need a witness chain, it solves that problem, right? You've got a sensor that's been, that's running in a black box on a drone or a plane. It's giving you exactly every single particular step that happened, and it's repeatable and traceable, which is important. All right, I'm blabbing here. Hopefully you guys can see my other screen.
You're not. This stuff's really important, and this is the stuff that helps us get our head around what you're building and how we can actually find a way to utilize it. So this extra explanation is really, really helpful.
Agreed.
Yeah. And again, I don't have all the answers, guys. I'm, exploring and learning and trying to explain the best I can. But some of these is beyond my ability to explain. All right. So Jed had a question earlier, which is interesting. He asked, how we handle decentralized state across multiple instances of root vector. This project has a layered distribution state designed to spread across several dedicated crates, which is kind of what I said. So we've got this idea of delta consensus. And we might want to dig into that slightly more here in a minute. We've got this idea of a consensus algorithm, this RAFT approach, which I mentioned. This provides the state machine election, log, replication, and quorum, similar to what you'd have in I think it's like Ethereum, probably. Then you've got this idea of a DAG consensus. A DAG consensus would be, if you're familiar with the blockchain world, this would be Avalanche, so if Raft is Ethereum, DAG is again, it would be like an IPFS or an Avalanche style sort of blockchain. It's not a blockchain in the way that Bitcoin blockchain, but for lack of a better term, it's similar. Then we get this idea of event sourcing. So this delta stream with checkpoints, relay, and compaction. So again, back to the delta. The delta is the vertical, the intersection, right? It's the state of knowing and understanding applied to itself. Sometimes described as that triangle icon from Greek, if you're in the Greek sort of alphabet. Causal delivery, vector clocks, and sharding. So this is my clustering capabilities. So this is how I would handle scaling this on a project that has hundreds of millions of users. Right now, my largest project has 100 million active monthly users. Shout out to these guys. Thanks for hiring me. But how do I handle that? So that's how I handle that. I'm handling that through a combination of the clustering and the replication to allow for a kind of eventual consistency in the system. Conflict resolution, how it all fits together. State flow. So now I asked it to explain this in a simpler terms. All right, let's go for simple. So think of root vector like a team of people all working on the same giant spreadsheet, but each person has their own copy. So think of RBF as their own copy. So RBF is kind of like a PDF file for like cognition. So who has the data that provides, that's done in the form of a shard. So instead of every instance holding all the data, we split it into 64 chunks or shards. A consistent hash ring decides which instance owns which chunk. When a new instance joins, only a small slice of the data moves, not everything. Remember, I'm the anti-blockchain. I hate the concepts of having to move all the data for like consistency and understanding and sort of conflict resolution, which is what essentially Bitcoin and Ethereum do, right? They're like, if you want to be a node in Bitcoin, you got to move all the Bitcoin transactions that's ever happened, which is stupid and unnecessarily to prove the work. I don't have to do that. I only need the deltas that are needed to prove that particular part of the work. So we have two different strategies, as I was trying, but badly trying to describe earlier. So we've got a sort of raft consensus. One instance is elected leader, all rights go through it. So that I guess would be centralized if to Jed's point, and the majority must agree before anything is committed, like a team vote. So in that instance, it's kind of like Bitcoin, right? It's people claim Bitcoin's decentralized, but it sort of isn't really decentralized from a completely decentralized approach. Then we've got this kind of frequent, idea of using CRDTTs, special data structures that can be merged without conflicts, no matter what order the data arrives. That is sometimes referred to as eventual consistency. That back to my quick protocol, that means I don't need the data to be delivered all at once in a sequential pattern in order for me to start working on it, which is important because in the form of my RVF format, the entire package could be multiple gigabytes, but I only need the first 4 kilobytes before I can start working within the structure of the package itself. So it grows, but it can be worked on before it's done downloading. Just making sense, or I'm hoping this is helpful.
So for number 2, you have a centralized writer that acts as the canonical source of all the data. It doesn't necessarily store all the data. It's an index that points to the other nodes which carry the shards where the data actually lives. Did I get that?
Yeah, I think that's about a way to look at it. So
okay. So in this raft leader thing, how does in the event the leader dies or is otherwise marked as, I think it was suspect was the term, how then is the new leader elected? I assume someone has it's elected amongst all these nodes, but all nodes do not know about each other. They only knew about each other because of the leader, right?
Yeah,
so how
does the system remain?
What prevents the system from creating a series of islands where,
yeah,
let's say, adjacent nodes elect a leader, but then a different island of adjacent nodes elects a different leader? How do they reconcile between? Does that make sense? And for those listening along in the chat, let me know if I'm not making sense.
I doing a question I can ask. Let's go Jeopardy on this.
Okay. How do decentralized nodes with only knowledge of adjacent nodes elect a leader under Raft?
Type that into Zoom, and I'll pop it in here. Right. But the moral of the story is I'm not using centralization, so it's not really a required question. I'm decentralizing the thing. No, I'm using the decentralized protocol. I can use Raft if it's a trusted network, but as I showed before, it's generally not required, right? And that's why I'm using the consensus algorithms and whatnot, which are decentralized. So that's you've got different architectures you can apply. Right now, if it's an environment that you trust, sure, you can use a centralized approach. All right, how do we decentralize nodes? Who knows presence? Okay, that's a good. Let's see what it says.
Which repo is this in? And maybe I'm querying the wrong one.
This is root vector. So yeah, this is my root vector, and there's it's, you know, millions of lines of code in here at this point. So you need to kind of point it in the right direction. All right, so what do we got here? Leader election when you only know your neighbors. Gossip first, vote second. A node can't vote for someone it doesn't know exists, so it happens in two phases. Every node starts knowing just a few seed peers, then A knows B and C, and B knows A and D, and C knows. So it's a hierarchical grid. It's the most fundamental part of my swarm structure, right? You've got it's in this scenario, and it's a hierarchical grid. So what you're really talking about is what happens if, you know, how do we handle fault tolerance? Phase 2 raft. Okay. How do we handle fault tolerance in a decentralized form? Something like that. I think you just got to ask Claude, to be honest. Fool around with it. See what you can what you can, you know, cook up
Are
with
there
it.
any uncommitted changes here? Because I'm cloning the repo shortly. So I can ask.
No, I just did a push this morning. I did a major update actually. Speaking of, there's a couple new crates that this is probably right up Stu's alley that might be really interesting for you. In particular, I created several novel new forms of no, that's a node. I want to show you. I want to show you the no transformer. Yeah, graph transformer. Sorry, a lot of stuff to cover here. I've been on a bit of an epic swing here. So what I did here, I created several new graph transformers. So what this does is lets you create mathematically proven sort of elements that can then be applied and understood using a sort of attention mechanism. If you're looking to sort of push into the further into the boundaries of really large amounts of information, like how do you scale to millions of nodes and understand the sort of physics of those nodes? So let's say you're doing drug analysis and there's billions of particular nodes, and understanding the causal effect of how those are going to affect, you know, people and other structures in and around it. This library is going to handle that sort of thing for you. If you just got a ton of information, let's say you're Google and you have the entire internet that you need to look at, this structure would allow you to traverse all that. So this is the structure for like super large data sets, billions and, you know, petabytes of data, and then being able to traverse that really quickly. So I've got a few different modules that I've created for that. Sublinear attention, which is probably the most interesting. The proof gated one, let's see, this provides the ability to validate each element within the actual graph state before it makes a decision, which basically means it's deciding on the decision of the before it makes the reasoning process that it needs to reason on, and then reasons on that reasoning. And that's happening in using a sublinear attention back to speed, really tightly constrained time frame. But if you're looking at sort of going down the rabbit hole of crazy, this is the one to look at. And I include all the various ADRs to show you how I built it. So if you go in here and you look at the ADRs, you can like here's the this is probably the most interesting for me. This ADR basically graphs sort of real world dynamics. Well, why is it rendering for me? Anyway, the real world dynamics would be like a world model, like from the particle level on up. So I can map the particles of a system using a simulated quantum state, which is what you'd see in that example I was giving you earlier, and then apply attention to it. So this is again absolutely insane, but the practical application was that planetary system that I was showing you.
Roof, have you tried Falcor DB? Have you checked it out?
No, what is it?
Pointed to your swarm. There might be a couple of things that are interesting because they're actually using the operation when they're doing the queries instead of Cypher.
Yeah, let's do it. Okay. Let's create. I mean, on main. Let's not work on main. So let's go here. Create new. BSP. And I gotta update my Claude code here, but whatever. There was a major update they did to Windows the other day that broke everything on Windows. New branch and review doc research. Filecore. I like the name. Filecore DB. All right. Let's see.
Yeah.
Let's see what. What's it built in?
Really interesting and faster.
Filecore DB.
I have a question.
Sure.
When you mentioned that amount of data that you were saying before in the project that you were mentioning before, or in the package, to handle that amount of data, you mentioned that RBF format will pack all that data in one file?
Yeah.
In a very small file to run in anywhere.
I can get I got this so small that I was able to create a seed and put it in a QR code. That's how small I was able to get it. So you can literally embed the core intelligence of the RBF cognitive system in the space, which is 2,000 bytes. So I guess that's 2 kilobytes in a QR code. So when you scan the QR code, then the seed then expands because it expands to available information to it. So the most basic could be like a QR code that then opens up in a browser, possibly, or whatever. And then once it's in the browser, it expands and downloads and optimizes itself based on that. So it's literally, I don't know if anyone else has figured out how to put a legitimate AI inside a QR code, but yeah, that's how small you can get it.
All you'd need is a large enough camera resolution to interpret the QR code, right?
Well, the QR code is limited, right? You can only put so much information in. I think it's like 2,000 bytes. So, but I was able to get it into 2,000 bytes is the moral story, which is tiny. Now it's going to download it's going to download other stuff at that point. Like I could do some basic stuff in 2,000 bytes, but really if I want to do anything particularly interesting, I'm going to have to bring other systems into play at that point. Now, the only thing I don't like about this Filecore thing is Redis. Like, why do I need Redis? It looks like you need to run it in a Docker. It's a Python.
The main application is saying the same thing when doing the queries, right? Maybe if you're able to extract the logic and then apply it somewhere, it would be really cool.
It's using sparse matrix. I'm doing the same thing. It just looks like a bloated version of what I'm already doing. I'm using sublinear algebra for queries. They're using linear. Yeah, it's similar in structure to what I'm doing, just slow and bloated.
There you go.
Yeah.
When you create the cognitive container, you're using Firecracker, right?
I don't need to. Firecracker is an orchestrator for bare metal. So you can use it if you want to use it on like an E2B style environment or like a serverless environment. Then you would use Firecracker. Now for like on my ESP32 or whatever, I'm just compiling the RBF directly to run on the ESP32 or an ARM-based processor, and that I don't need Firecracker.
As a binary.
Yeah, it's binary. Now you're going to have to compile it, right? So remember I was showing you earlier this download? Yeah, when you go here to download, download as an EXE or a DMG. So I'm compiling the RBF to be an EXE. Right, and then no installation required. You can just double click the EXE and it'll run CLI or desktop or whatever you want. No installation. Now, in that scenario, I'm compiling it for Windows or Mac. Right, so because it's Rust, I can compile it for different environments. Now, the core RBF itself is just a binary. So when I include it with a runtime, for example, when I've included in AgentDB as well as the MPX root vector, that includes the runtime. So I don't need to worry about compilation at that point. I can just run it through the npm runtime. So it'll just work, right? Because I've already handled that part of that problem. But if you don't want to use an npm, you want to just have it native, on the chip, bare metal, then you just compile it for that chip.
Got it.
Let's see. I've got the other one running too. Let's see what it has to say. It's almost done. Let's go back to the other screen. Too many monitors here to keep track of. Agent is complete. I got a file somewhere. No, it's not quite done yet. And by the way, if you're curious about how I build everything in RuVector in particular, which is kind of my lab, you're going to see the various ADRs. And the ADRs again is kind of the magic to how I can build all this stuff. Oops. Research Falcor DB. Okay, let's go there and see what we can see. Research Falcor DB. All right. It's not rendering that for a moment. I got to restart the VS Code. You're gonna have to look at it in. So Falcor DB is a high performance in memory property graph based on Redis, which is or Redis graph. It's got a shitty license. It's got lots of stars. Its architecture is built on a single foundation. Graph traversal can be expressed as sparse matrix multiplications. So, yeah, same premise. I've got the same premise. Generally speaking, of this idea of sparse matrix, rather than crawling through. Falcor translates cipher patterns into algebraic expressions by graph BLAS, topology, data model. Okay, let's ask stupid questions like how's it better or different than how's it better or different than RuVector? That's the real question I want to ask. And I'll take whatever's better and we'll integrate it. I'm gonna go full Claude code on Falcor.
And keep sharing the ADRs. This is very important, I think.
I'm going to create an ADR on this in a second. So what I'm going to do is I'm going to take the best bits of Falcor DB, and I'm going to create an RVF, and then we'll go ahead and do that.
I have a question, Roof. So for the you're showing the API earlier on for Cognitum, and where is that in RuVector in the repo? Where is that?
Sorry, what you're talking about? How I built the causal? What are you referring to?
The Cognitum API, right?
Oh, I'm that's my box. You're gonna have to buy one of my boxes.
Yeah, no, I get that. I know, I get that, but where's the documentation for it?
On the box, on the device.
Okay,
it's so you plug in device and it shows up and in your browser or wherever
you want. Documentation now to look at it to see what to build on it.
Well, it's between us. It's RuVector. It's just a
commercial version. Oh, I see. Okay.
It's a commercial version of it with a dashboard and a bunch of other stuff. And some people don't like CLIs, and for those people, I've got a dashboard and whatnot. Right. All right. Okay. So according to this, Falcor DB and versus RuVector, they're fundamentally different things. Falcor is a database. RuVector is a computation engine. They solve different problems at different layers of the stack. Falcor DB, graph database, storage, and queries. I don't know if I'd agree with that. They're building it in C. I'm building it Rust. They're doing stores. I compute over graphs. Falcor is better persistent graph storage. Well, I would disagree with that. I've got persistence. Okay, Claude, you're letting me down. Okay. What about the RuVector, Postgre and persistence capabilities. That's the problem with my repo. It's a bit too big for even this thing to understand.
It keeps forgetting about those. Yeah.
Yeah. So GraphRag SDK, turnkey LLM integration, no graph aware RAG. Well, yes, I do. I just showed you the graph aware RAG. It doesn't.
It's built. It's embedded in ROS using REDB, right? So that's why it might not be able to read through it.
It says it's complementary, not competitive. Okay. It's a Redis module. I think the system doesn't. I think in this particular scenario, it doesn't quite understand what I'm doing to a point to give it because everything it said here isn't actually true. A lot of it's not true. Like at least in terms of my capabilities.
Have you built an RVF on RVF, Ruv, so that it understands everything it is, can do, etc., in a way that Claude Opus doesn't keep getting confused?
Yeah, I did. There's where the heck did I put that? You're talking about like an NPM module? RVF. Yeah, you can hear all the RVF components. I can't, it's not rendering for some reason. I'm not sure what happened to my VS Code, but this is the document. This is what you need to point it at. And it's published. I published both as a npm and a crate, so you could run it in like Cowork or whatever in Claude, that kind of thing.
I would like to make a note here, Roof, if you allow me.
Sure.
I think this is exactly what will happen most of the time. Whoever is trying to wire something that you already built. Claude is not smart enough to understand how to do it, or still missing a lot of the implementation that you already have. So I have to go push and push and push and finally understand what is actually implemented. So my idea was that we have an MCP with all the projects, with all the documentation, all indexed correctly. So we don't have to keep pushing, just to have a roof MCP
you're talking
with
I think
everything.
You're talking about, yeah, I think you're talking about my Ruby MCP.
Yeah, but I don't know if Ruby is actually with every single package.
No, I haven't got around to doing it. I get too much crap. I don't know.
I know. So my plan was to take Ruby and actually create a full updated for all the packages. So, and include it in Cloud Code. So every time it will be able to go in the MCP, find the technology that we have available, and not try to reinvent it. And then it come back and say, okay, I can use this, and this, wire it, and we have the solution. This will be the most useful for everybody trying to use all the packages.
To get going, Ruby is probably a good place to start. I built so much crap, this is already out of date, but you can tell here, there's 250 packages. I'm well into like 1,000, so I would need to add another 700 probably. But this is probably a good starting point. It's organized by structure. There's an MCP for all of it. You can interact with it. It's MPX Ruby. You can see there's just a lot of stuff in here.
I don't know if my idea was good or bad. It just pushing ideas here.
Jose, that's what I tried to do with the Ask Ruv. Now I just put it in the chat if anybody wants it. It literally goes out every night, looks at 148 repos from Ruv, takes down all the latest stuff, stores it in RuVector. I created a knowledge base and an MCP against that. I've made available for you guys if it's useful. I'm still trying to get my head around it myself to try to do just that, because I think a lot of us are struggling with how do we make sure that Claude is smart enough to understand what Ruv is doing. And so I've got it looking on a daily basis. If you click on the knowledge base and the knowledge universe, it'll show you on the left kind of what's been updated, what the latest repos are, things like that, just to kind of give a flavor for some of that stuff. Whether or not it's all the right answers, I don't know. I've been really just trying to get it to get its head around all things Ruv, because I think, honestly, we all have a challenge kind of keeping up with that rate of change. And we really have a frustration with Claude being a couple, 3 or 4 hops behind And I, like Jose, have to spend lots of time trying to catch it up on the advanced concepts you do every day.
Stuart, if I may offer some feedback,
Of
add
course.
also the GitHub commits, not just the repo contents, because Claude is usually good about leaving notes within the commits of what was intended, and that can be reconciled against the actual pushed code.
Yep. Ruve, if you click on the button on the left that says knowledge base or the knowledge universe, right, that'll start to tell you kind of what's there, the latest, how soon it was updated. I've got it sweeping on a nightly basis, kind of pulling things down to read and pull in. And if anything's new, if there's a new rev, it starts running those. At least that was the intention. And it's all kind of built with the latest and greatest, but who knows if it's the right thing. I think in an hour you could do the stuff with it that would turn it into something that would deliver that. And if you click on the knowledge universe, I'm trying to get it to if you click on the ball in the middle.
That's cool.
And then each one of those allows you to traverse up and down the path to see what are we learning, what's there, how do we dive into it, up 3 or 4 or 5, 6 layers and levels, because I can't figure out what the hell's in a root vector. I know everything is, but so I'm building this to try to understand what do we do, where should we use it, why should we use it, what are the advanced techniques, and how could we explain to Claude Code, even if it's Claude Code at V3, how does it know some of the other crazy, as you say, that's in root vector that it can and should be using to dynamically or novelly solve the problem you're asking it to work on?
Yeah.
Right approach, wrong approach, Ruve, you would know, we wouldn't.
I'm just experimenting. Like you're seeing the output of my experimentation.
Sure.
I'm just trying to see where the rabbit hole leads. I think that what you're doing is visualizing it in a way that's useful. And we should package this whole thing up as an RBF.
Take it.
Yeah.
Listen, you contribute all your stuff. If this is in any way useful, please take it, roll with it.
Let's add it to my Ruby my Ruby package and then package that up as an RBF, and then you can just basically point it at that. This is cool. This is really cool.
I would definitely use this thing 100%.
Yeah. I actually thank you, Stuart. I feel better now. I'm not alone in this situation. And then another
We're
thing.
all feeling this way, Jose, brother. Believe me.
Yes.
And another thing is just make it update automatically based on it will check all your repo and everything.
It does.
You don't have.
It happens on a nightly basis every single
Correct.
repo.
Okay. Because
and it even looks for other new things he's done. Because Ruve, I never know where the heck you're taking some of the new crazy that you're inventing just this week.
Questions,
sometimes they're in RubeNet and sometimes they're somewhere else that you're working on them.
Question, if you don't mind, Stuart. Based on Jeff's comment, I agree. It's very useful to include. I don't know if you're doing that as the question. The issues there. To get the intent also, that really helps.
What was that? Sorry, I missed the question, George.
Yeah, in the GitHub you got issues, right? Based on those, you can find the intent on some packages, because otherwise Claude got lost in missing connection or while
I kind of kept this out of Claude. I just had it be Claudeflow v3 and root vector build this so that. Because Claude gets confused too much dealing with Ruve stuff.
Yeah, exactly.
Is that the right way to think about it, Ruve? To have Claudeflow v3 and root vector be the two combined to go build it?
Well, yeah. There's a collection of stuff. If you want to think of like conceptually, my root vector is my lab. I just create and I put it out there. Then it trickles up into AgentDB and Agentic Flow. And there's 2 new versions I'm pushing out today of both those packages, which is more of a commercial sort of package of it. That's like, how do I use it in a business kind of packaging? And then ultimately, once that's sort of, I know there's no major bugs in it, then I push that to Claude Flow. I'm in the process of doing the Claude Flow push, and that'll be Root Flow here shortly. And that's my stack. That's what I build. So if I need an agent that lives and breathes forever, then that's, my Agentic Flow package. Like if I'm creating, OpenClaw or whatever, that's how I would do it. I would use that package. And it's got everything, basically. Those Agentic DB and Agentic Flow has everything worthwhile. I've stripped out the crazy. Some things are just so out there that you position it and people think you're insane, but it's positioned a little less insane, basically.
All right. Well, can I offer this to you, Rube? Is that useful at all? I'd be happy to invite you to the repo, and you could take it and run with it however you wanted.
Yeah, send it over. And what I'll do is I'll package it up as an RVF and put it in Ruby. Which
beautiful work, Stuart.
Thanks, awesome. but look at it first to make sure it's what you want it to be. Me trying to deliver your stuff and you trying to deliver your stuff are two different things.
Yeah, I get it. There's so much stuff here, and Claude half the time thinks the stuff I've created is too crazy to even be true.
And that's my concern.
It's true. Like you saw it here before. It's like, oh, your system is too crazy, right? Oh, no, it isn't. It actually works. So like here, I said, what was the root vector Postgre and persistent capabilities, and it says, oh, look, you've actually got a Postgre implement. Well, yeah, that's my core thing. Like you can run it all in Postgre. Like, come on. And then it says, add solvers, and it does, my embeddings and all that kind of stuff. And yeah, this is probably the most. This is probably the most appropriate comparison. Nobody wants to use Redis. It sucks. I chose Postgre, and it can run in or outside of Postgre like SQLite. No near zero loss. It backs up. You got replication, consensus. If you're looking to build the state of the art in a business, I at least the businesses that I work with, it's got everything you need. And you just got to discover the pieces that you need, which is back to Stuart's component. Now, according to this,
and just to say something before we continue about the intervention from Jordi and Jet, I think it's very important for this kind of system for helping Claude that the intention of what is the package for. So the Git implementation are very important for him to know it, because I tried. I was working on this for a few weeks, but this implementation from Stuart is even better. But I think this is important, the intention of the package, so it will understand exactly what it's for. Sorry.
Yeah, that makes sense. The other thing that I might suggest you do if you're curious about exploring it, point it at my ADRs. Everything I've built over the last few months is an ADR, and they're all interconnected to one another. So you could basically create an index of the ADRs, which are inherently a kind of multi-dimensional structure, and then you can map it pretty quickly. Now, I haven't shared my personal root vector learnings, which maybe I should, but I'm just worried that I might expose stuff that I probably shouldn't. But if you look at my environment here, I've got 6 gigs of data that underpins my learnings. And this was a question I think Jed or someone asked earlier, like, how does it know what you've already built? It already knows everything I've built. I've got the master brain. So the reason I can build as quickly and as efficiently is because its system knows everything I've done to get to this point in the system. So I should probably export that so you guys can use that.
You've put that into root vector Postgre?
No, this is running just native. This is just running natively, and as I think it's an RVF at this point. Can we export all the learnings of
so it's 6 gigabytes of text?
No, vectors. The Cloudflow, what am I call it? Memory in a RVF format that others can use based on everything we've learned in this repo since the first day of its existence. I don't even know. Do deep review and create an ADR. I'm gonna say other users will use this to kickstart their Roo vector development journey. We're okay.
Well, I actually have one question about that memory recorded. Is that in some way able to lose it if we force installation of Cloudflow or anything else?
Possibly, but I've got, if Cloudflow has checks, so when you do the init, it actually looks at your existing memory and then ports it to whatever crazy concocted scheme I've come up with. So so it basically imports it. So remember the sort of, when I first launched Cloudflow in June last year, it was a JSON, and I just did, kind of appended JSON files. And there's some remnants of the JSON still in there for certain things that just JSON's fine. And then I moved to SQL. Then I realized that I had some issues with SQLite. Then I had some issues with cross-platform SQLite. So then I moved from using better SQL 3 to SQL.js, which was a WASM-based approach. Then you start seeing the memory.db files and the swarm.db and a few other files that created a binary. And then that was my sort of, if they're doing a binary, maybe I could do a binary. Then that inspired me to create Roo Vector. And then I'm like, I can actually create a multi-layered binary. And now I'm in the process of replacing all the sort of SQLite binaries with my RVF style binaries. And then so in the updated version that you'll see some of it right now in AgentDB, and in probably an hour or two, you'll see it in Agentic Flow, but I migrate those binaries from SQLite into the RVF format. So I'm kind of moving it. Now, if you use the force option, the force option could potentially overwrite your claude.md and some of the other files that you have. So be careful with the force. There's an upgrade command. That's what I use. And there's upgrade settings. The upgrade settings will give you like the most recent status line component that you saw when I shared my screen a moment ago. I've optimized that a bit because Claude Code keeps mucking around with the status line, little dots popping up and that kind of crap. Yep. So I've had to do several updates to that based on their issues, not mine, but that's the path that I'm taking.
So that the 6 gigs right now is before you convert it into RVF. What is it in right now?
Right now, it's in a SQLite form.
Okay.
Yeah. So what I'm going to do here, I'll publish this later today for you guys. What I'll do is I'll give you a kickstarted version of my memory, and then all you need to do is point Claude at my memory and say what the heck is in this thing, and that'll give you a vector graph memory structure of everything I've done to build everything in this particular repo.
That's amazing. And we have to give it a link to the RVF crate as well, right?
I can, what I can do? I've got a runtime in Roo Vector and the MPX Roo Vector. I can make it available as part of my MPX runtime for you, and all you need to do is just execute the Roo Vector runtime, and it'll just import it and use it. Something like that.
Why would that be necessary? Couldn't QDAG just be used so everyone is federating off of your copy, Ruth?
Yeah, I could do that too.
Spit it up.
I've already
ship it. Let's go.
Yeah, I've already. That's actually not a bad plan. If I do that, then we could do a federated, model where I'm the
collective intelligence, right?
Exactly.
Yeah, collective intelligence. And then anytime I do something crazy. Now, the only problem with that potentially, and I'll have to do some PII stripping and environmental variable stripping, which I already have. But other than that, yeah, I could use a central node on Google or something, which is probably good enough. And then you just activate the central learning component in maybe MPX Roo Vector, and then you'll automatically get whatever I do.
Well, it's bidirectional, right? What? So that other learnings can be fed into the memory.
Hive mind. It's a hive mind structure, maybe.
That would be great.
Yeah.
And then the expectation is everyone's node is functionally decentralized, and therefore they learn from each other or each other's learnings and append to their respective corpus in order to solve problems relative to that specific node.
Yes. But remember that I mentioned like last year about this proof, about sharing the knowledge. And you say that you implemented it in APF. The one that you have for
IFPS.
the plugin system. I think you have something already in place because I remember we talk about this sharing memory or sharing knowledge. Isn't it not already in place or something like that?
Yes, you're talking about my transfer learning. I've got it all. I just got to use the stuff we've already built. Yeah, the transfer learning component would also be a way to do it. And that's how I'm doing it in Claude Flow. There's the ability to export. And I think actually this might have been your idea in Claude Flow. The ability to export the Claude Flow learnings amongst different environments. So I've already built that.
Yes.
Correct. So that will be the best, I think, to start. I mean, if you want to share knowledge.
Yeah, there's certainly no shortage of ways we could handle it. But I think what you're suggesting is maybe there's a way for us to federate our knowledge and share it in basically real time.
I think the important part is to keep everything opt-in as opposed to opt-out. So make available for participants in the network to opt into the knowledge, but do not push the knowledge onto them. Make sense?
Yeah.
All right. So this, I think I hear what you're saying. You know, I'm read only kind of thing. You're reading, but not necessarily writing. Well, I'm writing, you're reading.
I can read what you write. You can read what I write. I do not write into your space.
Correct. But actually,
the Rubeco format actually has this kind of blockchain, right?
It's already built in. Can we? So let's just update this particular. So this is the initial RV. The spec. And all right. So where I got too many things open. Where did I put it? Here. RVS knowledge. Yeah, here it is. I don't want. Oh, it's doing for Falcon. I don't want Falcon DB. It's confused. Regardless, can we create a federated, an optional federated RVF format that allows real-time learning to be exported and shared with other users as I create new modules, crates, stripping any PII or V, but including the core learning. We call that transfer learning. Using the Google. We should put that as Google Cloud. I'm just going to let it figure out what that should be. For this, I'm going to give it a little extra helping hand. I'm going to use the goal. No Falcon. What the heck we call it? No.
Falcor DB.
Yeah, I don't want Falcor. Falcor DB. Create a new branch. Actually, I'm going to do create a branch at the beginning because it's
Roof. Sorry.
Created RVR. Yeah, I'm late for my Lex call. I think I feel my phone buzzing. Create new federated RVF. Federated RVF. Start mission. All right, that's where I'm going. We're going to create a federated hybrid shared learning system using an RVF format. And then we're going to tie that into Stu's dashboard and and then and then I'm gonna include the GitHub synchronization. So any commits will auto populate. One shared brain to rule them all.
Wow.
That's perfect. I just made my repo public, and I invited you, Rube, specifically to do anything you want to it, to take it, change it, add it. I don't think I have Ruby in there. I think I just have the GitHub repos. So whatever else you want to add, and I didn't have it looking at the ADRs yet. So you're right. That's probably a great call.
Yeah, this is cool. So cool. Thank you. Thank you.
All right, sounds good, guys. I'm late, so sounds good. I'll talk to you guys later.